Exponential functions are the opposite of linear functions because instead of adding and subtracting, they multiply and divide. So in example 1, we're going to determine if the situation is linear, and that should say, or exponential. A horse is traveling at a constant speed of 35 miles an hour. That means for every hour, they are traveling 35 miles. Constant should definitely make us think linear, and the fact that they're just traveling at the same speed and the same mileage for every hour is a linear relationship. Because at hour 1 it would be 35, and at hour 2 it would be 70 because I added 35, so on and so forth. So this is linear. A car depreciates, that's a very key word, at 12% each year. I know the word depreciates comes from exponential functions because we talked about exponential growth and decay. And 12% means I'd have to convert it to a decimal and multiply it by whatever value to determine what 12% is. Multiplication, like we've said before, is exponential. A credit card company receives a payment of $120 per month. Again, $120 every month, not changing. $120 constantly is linear, because it's adding. After each round of a tournament, half of the teams are eliminated. This one is a little tricky. When I get to ones like this, I like to think, let's say we started with 16 teams. After the first round, half of them are eliminated, which means there's 8. So it decreased by 8. After the second round, there's 4, because they broke up into half again. So from 8 to 4. That's not constant. That's not subtraction. That is division of divide by 2, 8. Divide by 2, 4. And you could keep going until you had the winning team. So this is an exponential example. Our second example says determine the value that will make the table exponential. Again, we know exponential is multiplying and dividing. I know that multiplying makes things increase and dividing makes things decrease. So I'm going to look at my y values and determine if they're increasing or decreasing. 3, 6 to 12. That's definitely increasing, so there must be a multiplying pattern to this. So I'm going to think 3 times what gives me 6? Well, 3 times 2 gives me 6. I'm going to try multiplying 6 by 2 to see if I get the same answer. 6 times 2, yes, does give me 12. And therefore, 12 times 2 would give me 24, and that would be the missing value.